Hello everyone, this is Zehao from the Duke University, and today I want to show the customer's optical hardware demo. And here it is optical devices in the customer programmable optical network. And on the left, we can see that we have currently an S320 space switch, and the transceiver, the DICOM switch, and 8 Lumentum white box 20 ROADM, different lengths of fibers through, and even dark fiber that goes through the Manhattan. And on the right is the data center at the Columbia, where we can see the optical devices like the space switch and ROADM, and also the fibers on the bottom and on the top. And there are also computer servers which control these optical devices. And in today's experiment, we want to show the client, which talks to the end ports, the edge cloud and the center cloud through our optical fiber. And we want to do the optical switching between the edge cloud and the center cloud through a short port or the long port. And there is also COM source which connected to the two ends of the long port, which is used to emulate the background traffic. So for the first part, we want to show the short part where the client is talk to the edge cloud through the short part. The first thing we want to observe is that this client is pinable to the edge cloud. So let's log into the console server to see. Okay, so here it is in the Cosmos lab page, and we want to log into our client, which is server 1, cell 1, which is our client. Now we are in the client, and let's check our topology. So let's go to our control page. So here it is our optical server, which control all the optic devices. And we want to turn our topology to the short span. Let's do 1. And the script will do the connection for the current switch, and also for the different ROADM, and add connection to the current, and also add the connection to the WSS of the ROADM. So it seems it is done. So let's go back to our client. Let's check here. So our client now is pinnable to the edge cloud. So the edge cloud is 2.1. Let's see whether we can pin 10.101.2.1 is our edge. So it shows that our client can talk to the edge, and the time it takes is about 0.2 microseconds. So how about whether our client can talk to the center cloud? So the center cloud IP address is 2.2. Let's see. Okay, it seems like the host is unreachable, so the optical link is not established between the client and the center cloud. Let's go back to our slide. Yes, so we have observed that we can ping from the client to the edge cloud, but not to the center cloud. And the next thing we want to check is the spectrum after the first booster. So we can see that we load a transceiver channel to the mux, and also the background traffic channel from the console. And so those channels pass through the mux and go into a booster. After amplification, we will observe as the ROADM 1 cell 1 booster out. And our expected spectrum is on the left. We will observe some three big groups of the background traffic channels, which is come from source. And we also will observe a transceiver channel, which is in the middle. Let's go to our optical control panel. And here it is a script we wrote to show the real time of the OCM reading from the ROADM. So here we want to see is ROADM 101 and the booster out. Okay, so it will create a figure as the folder of figures. It's the ROADM 101, the booster of, I see. Okay, we see there is three groups of channel, big channel, which is emulated by the console. And there's also a small channel, which is about like the number of channel 62, which is the channel for the transceiver. And we also see there's a big spike in the middle of the console channel. And we'll come to this later on. Yep. So we see the spectrum we expected. Then we go to the next slide. So we also want to check. For now, the optical connection is only established between the client and the edge cloud. We don't want to see that the transceiver channel is on for the second hoop, which is connected to the center cloud. So expected spectrum at the ROADM 2 large one booster in, it will be three background traffic channel, but without the transceiver channel. Let's go to our optical server and do the real-time OCM reading. So here it is 7. So the ROADM 2 large one. And the booster, let's see. So the booster in. Booster in. Okay. Okay, we see that we still observe the three large console background traffic channel, but there's no longer the transceiver channel. Let's go back to our slide. And another thing we want to show is the cascading effect in the block channel from console. So as we remember that we created three group of the background traffic channel, which get from the console and get into the mark. And however, at here, we block the 45 channel, which is in the middle of one group of the console channel. We block here. So for the 45 channel, it only comes the noise. And after that, the noise goes into the booster. So after that, the noise goes into the booster. And if we do a measurement at here, what we will see that there's a big spike here. So it means that the 45th channel is blocked and there's only little noise. The edge noise comes from booster. Let's check that. So for here, the ROADM 101, we see that there's a big spike. However, as the booster has some ASC noise added to it, so we see that the power is a little bit higher than noise floor. So going back to our slide, after the signal goes through the fiber line, there's another preamp which adds additional ASC noise to the block channel. And if we do another measurement at the ROADM 2 large one booster in, we will see that the block channel will have much more power than the noise floor because the booster or the preamp will add ASC noise to it, to that block block channel. So here is what we just did measurement, and we can see that the block channel has much higher power than the noise floor on the bottom. Yep. So we observe what is expected, the spectrum for the cascading effect. After that, we want to switch our connection from the edge cloud to our center cloud. So the first thing we need to do is go to the optical server, and we run our script and go to the long span. So again, it reconfigures the client and some connection, and also reconfigure the rodent and as reconfigure the WSS connection. Okay, it seems done. Let's go to our client and do the ping. So for now, our client is supposed to talk to the center cloud, so they are pingable, but however, it cannot ping the edge cloud. So let's see what happens. So here we are still in the client. We are in the server 1, Zehao Wang, and we want to talk to the center cloud, which is 2.2. In the short port connection, we cannot talk to the center cloud. Let's see what's going on now. Okay, so we can see the client can ping the center cloud. And another thing we can observe is the time. So the time it takes is around 0.5 microseconds. So it's almost twice the time it takes for the short port, which is 0.2 microseconds. And let's see whether we can talk to the edge cloud. Okay, it seems like we cannot talk to the edge cloud because of the optical port change. The next thing we want to do is we want to check the rodent to large one booster out to see whether there's a transceiver channel, which we can observe here. So where we didn't observe when we do the connection between the client and the edge cloud. So we do the real-time OCM measurement where we want to read the rodent 2 large one and add the booster out. Okay, we got a new figure from the booster out, and we see again that we have the channel as a second hook of the transceiver channel, and look again at the spike here. We can see that the spike is like higher power than the noise floor, which is due to the cascading effect we just covered. Okay. So the final thing is that after the communication is done, we will need to close the transceiver connection between the client to first the edge cloud and the center cloud. So let's log into our optical server and run our screen. So we will type 3 for this connection. And here they will just block the transceiver channel. And let's go back to our slide. So here now the connection is blocked. And if we do a measurement at the rodent 101 booster in here, there should be no transceiver channel, and we can only observe the background traffic channels on here. So let's go to here and do our OCM reading where we want to measure the rodent 1 cell 1 and the booster in. Okay, and we check the figure. So what we see here is that there's no longer the transceiver channel can be observed from the OCM reading. Okay, thanks everyone for listening, and let me know if you have any questions.